Today we want to be looking at current divider rule. Now if you look at the circuit that is displayed in front of the screen, we have a circuit that has two resistors connected in parallel. Now in the previous video I've already explained to you what it means by a resistor should be in what? In parallel. But for those that are just coming for the first time, I will have to explain. Now it's connected in parallel, that is R1 and R2 are connected in parallel. Why is it R1, R2 connected in parallel? Because there's a voltage source in this circuit which is given as Vx, and the voltage source produces what is called the current I total. And when the current flows, this is the current flowing, when you get to point A, the node here, what happens? There's a split. And when there's a split, it means that what? Two different current will flow through these two resistors. So because of that, you see both of them are in what? Are in parallel. Now, in this kind of circuit, if you are to calculate the total resistance, we call it the equivalent resistance. We say that the arrow subscript EQ, that is arrow equivalent, is equals to the two resistors multiplying each other divided by the two resistors adding each other. That is R1, R2 over R1 plus R2. Sometimes you can use any subscript for it, but we'll use arrow as the symbol for the resistor, right? Now, that is to calculate for equivalent resistance. Now, the next thing is, if we're now told that we want to know the amount of current that will flow through the R1 and the amount of current that will flow through the R2, that is when current divider rule comes into play. Now, look at the idea here. I'll say my I1 will be equals to what? I'm going to repeat the formula for the resistors in parallel, which is saying that R1, R2 over R1 plus R2. But there's something I will not include. What would I not include? I will not include R1. Why would I not include R1? Because of what? I1 is flowing through R1. So if I'm writing it now, I'm going to say that what? My I1 is equals to R2 divided by what? R1 plus R2. Now, since I've removed R1, I need to replace it with something. What will I replace it with? I'm going to replace it with the total current in the circuit, which is called what? The I total. So that is how you find for what? The current flowing through R1, that is the I1. Now you do the same thing for what? For I2. If you are rewriting that formula in parallel, you will not write what? R2. Why are you not writing R2? Because of what? I2 is flowing through R2. So I'm going to say that what? My I2 is equals to what? R1 over what? R1 plus R2. Now all that is to replace the R2 that I'm not writing, I'll use my I total. So this is my current divider rule in short. Now to enhance your understanding, right, I'm going to associate figures to those resistors and the voltage source. Now let's assume now a question comes like this, and we are told that the R1 resistor is the R1 resistor is 20 ohms, the R2 resistor is 5 ohms, the voltage supply is 60 volts, right? And we're told to look for what? The I total, the total current that is being produced in this circuit. Now, the first thing you first of all do in a circuit like this is to calculate the equivalent resistance, whether you are told or not. So we say that the R equivalent, like I said earlier, is giving us R1, R2 over R1 plus R2. Now what is R1? R1 is 20, R2 is 5, divided by what? 20 plus 5. So we're having 100 over 25, which is equals to what? 4 ohms. Right? Which is equals to what? 4 ohms. Now, we've gotten our total resistance in the circuit. Now we want to calculate the total current now. Now recall, there's a formula that says that V is equals to what? IR, and that is what? Ohm's law. Right? So where the V is the voltage supply or the voltage source, and the I is the I total multiplied by the R, which is what? The R equivalent. Now if I input the parameters that I'm given, the data given, my V supply is giving us the 60 volts. My I total is what we're looking for, multiply the R equivalent, which is what? 4. Now if I make my I total the source of the formula, my I total will be equals to what? 60 divided by 4, which is equals to what? 15 ampere. Right? So that's the total current that is produced in this circuit. So let me input it there. That is I total equals to what? 15 ampere. So that 15 ampere will flow to point A. right? And it's going to split. Now when a 15 ampere split, we don't know how many is splitting to R1 or how many is splitting to what R2. That is where we are now going to use our what? Our current divider rule. Now I told you earlier, if I want to look for I1 will be equals to what? R1, I1 will be equals to what? R2 over R1 plus R2. I'm not including the I1 because of what? The I1 is flowing through. I'm not including the R1 because of what? The I1 is flowing through R1. So what I replace it with? The I total. This is what I explained earlier. Now if I input my parameters here, right, I'm going to be having the R2 is given as 5 multiplied by the I total, which is calculated to be what? 15, all over 20 plus 5. And that will give us what? 75 all over 25. And when you divide 75 by 25, we're having what? 3 ampere. Similarly for I2, just like I explained earlier, I2 will be equals to what? R1 multiplied by I total over R1 plus R2. Now if I input the data I have, the R1 is given as what? 20 multiplied by what? The 15, which is I total, divided by 20 over 20 plus 55, right? So in doing that, it will now give us 20 times 15 is 300 over 20 plus 5 is 25. And when you divide them, you'll be having 12 ampere. So it means that what? 12 ampere is flowing through the R2 ohms and 3 ampere is flowing through the R1 ohm. So that's why they do say that what? Current flows more through the path of the least resistance. You see the current is flowing more through the 5 ohm because of what? The resistance there is smaller. Is that taken? So, and it's flowing less into the R1 ohm because the resistance was is bigger. And if you look at this, we do say something that the current in a parallel, the voltage in a parallel connection is always the same. So if you multiply the I1 that will give it to be 3, multiply it by the R1, which is 20, you have the same voltage. So we say that 3 times 20 is 60. And if you multiply 5 times 12, you also have what? 60. Because the I2 is 5, you multiply 5 times the R2, we have what? 60. The R2 is 5, the I2 is what? 12. So 5 times 12 is what? 60, because that is how you want to calculate for the voltage. So we say the voltage in a parallel connection is the same, right? While the currents are what? Are different. So if you found this video helpful, please don't forget to click on the like button. Also subscribe and share. Thanks for watching.